you to Larry Felker.
Hello. This covers all of the very basics of replacement for pneumatic actuators and controls. And my email is on the very last slide, so you can always write it down and send me separate questions if you want. Here's our agenda. It's fairly straightforward. So here's our introduction. I have mostly pictures of electric actuators, so I'll use those here, but the principles for the pneumatic are exactly the same. Sometimes don't try to replace the actuator. If the dampers are shot, I know it costs a lot more money to replace a damper than an actuator. However, sometimes it's the right thing to do. So there on the left side, we see some damper blade hung up. There's no way you're going to get that thing to work correctly again. On the right side, it's a code violation right from the beginning. They cut into the drywall. So if possible, you can pull that damper back a ways out of the wall and sleeve it and insulate it. But strictly speaking, that damper should be replaced. So give that some thought when you find some of these really old bad ones. Here's another example. It's a terrible technical application. None of the parts are available. This is an air balance negator spring damper, about 30 years old. But on the left you see a crank arm. It's got a spring in it to tension the fusible link, which is connected here. The method being used is archaic. You've also got springs actually connected to the damper themselves to posts that are hidden here. And then you've got a latch here that connects. This is really primitive, and that damper should be replaced. Putting a new actuator on is a real pain in the neck. It can be done, but I recommend against it, and it's always questionable whether the fire marshal or building official is going to approve it. You should always try ahead of time. So mounting, some pneumatic actuators just came off the axle shafts, so we see the actuator there, and we see the damper shaft, jack shaft, and it's going to be easy to replace these because we can take off the old actuator and just drop a Belimo over the shaft. We don't use the crank arms or any of the parts anymore. So here's a picture. You can see that at the top it's just tad hidden, but the left white arrow points at the actuator, and you're not going to try to use that linkage or the crank arm and ball joint. What you're going to do over there on the right arrow is drop the actuator over the shaft. You're probably going to keep the old pneumatic base. It makes a good place to mount our anti-rotation strap. This is that same one with the old motor removed. You've got a shaft sitting there, and then here's how that gets replaced. You're just going to drop direct couple right over the shaft and then wire it. So here we have the shaft, the actuator, anti-rotation strap. It was scored and cut off, broken off, but it's sitting there underneath the actuator to hold it. So the replacement is fairly straightforward. On the left side here we see the old motor connected by crank arm ball joint, and on the right side we see what it would look like just direct coupling an actuator to the damper. So the mounting is typically straightforward. On the left side here now we have an internal mount, and those can be done a number of ways. The floor, if it's available close enough, well, you can mount the actuator with one of our angle brackets on the floor. or you can actually mount to the damper frame as we show in the picture on the right. These, of course, take more work. Here's a few examples of how linkage mounting had to be used. That one on the left side, well, you can see the shaft was very close to the wall, and you couldn't get the actuator over it because the actuator hit the wall. So you did have to use a crank arm, and then mounted the actuator where convenient. Right side shows it had an external linkage connecting two damper shafts. So they put a new longer rod on and a crank arm, mounted the actuator to the shaft via the crank arms and linkages. Note that they put a 2 or 4x4 box in here just so they had some place to make their electrical connections. Dampers. It's always best to start thinking about the damper, not the actuator. So if you take a look at the old damper and make sure you know how it worked and how it functioned, then you can decide what the best way to add controls and actuator are. So that one on the left there happens to have been, those are Phillips P150 motors. They're non-spring. There's a spring on the shaft, which has to be disabled before you put new actuators on there. As it was, I looked at the damper and said, oh, you ought to replace the damper, and the inspector had already approved it. And we went with the actuators and everything worked fine. But we had to investigate a little bit how it works right. You bump into a lot of negator spring dampers on these real old ones. So over here on the right, that spring gets torsioned when the motor drives the damper blades open. And then the motor was non-spring, and even the pneumatic ones, they'd go ahead and with this same method. This rod is a fusible rod. If it melts at 165, then this spring pulls the damper closed. And again, there's a latch plate here. This one happens to be a Ruskin. So these are repairable if the damper shaft extends, and it does here. We have a jack shaft, and it goes outside the damper, so one can get to it on the outside. You replace the fusible link with a ball joints fit right in here, rod to the ball joints on the damper blade. So it's not all that difficult. No parts are available. It has to be rebuilt, but you can replace the actuator, and a lot of them were pneumatic. Sometimes you find shaft springs like this one here. This was what was controlling it, and then you had a fusible link here. There are times when you have to replace them. You disable the spring by removing it like this, and then you put in a new thermal sensor. So here's what your typical electrical direct coupled is going to look like. You're mounted over the shaft. That part's straightforward. And then you have your 165F primary heat responsive device. So as I say here, a good 80% of them are very easy and direct coupled. 20% of them get weird, and you have to investigate how they work. So the controls. So typical on the pneumatic controls, although it was done 3 or 4 different ways, we start over here on the left with our air pressure. So the tubing ran into an EP relay. Common to normally open. If that EP relay isn't powered, air is dumped out of the actuator and it pulls the damper closed. If we're powered, we get air pressure, it goes from the normally closed to the common, pressurizes the actuator, drives it open. They were always a couple of ball joints, linkage and crank arm. The pneumatic ones are pretty easy to do. So here we have a picture of typically EP relay. Then whatever controlled the EP relay has to be investigated. Sometimes it was a smoke control system, a relay off of it, of an area smoke detection, or it could have been a local smoke detector, or in some cases, as maybe only 20 years ago, we would see an electronic fusible link. Sometimes we had air valves, so the fusible link held a clip and air could pass through to the actuator, open and close depending upon whatever else was controlling it. But if that fusible link melted, then it would dump the air out of the actuator and spring the damper closed. Sometimes they were right in the wall of the sheet metal sleeve. Sometimes they were outside. But the fusible link was always in the damper airstream, because that's what you would get your heat buildup. So air valves did exist. Sometimes you'd see two air valves. We had two section damper. There were two actuators, but they were both would close if either an air valve fusible link here or here melted. So you merely have to look at it and see how it was being controlled. This is the most normal wiring that you're going to see for for 85% of your fire and smoke dampers. You got a relay contact or a smoke detector contact here. It's normally closed. If smoke is detected, that opens, cuts power to the actuator, which springs the damper closed. You also have a temperature sensor, primary heat responsive device in UL's terminology, inside the airstream. And at 165, this would pop open. It's manual reset, and you'd cut power to the actuator and it would spring closed. All the damper manufacturers have one of these on their current dampers. If you're replacing a pneumatic, you may have to put one in. It's quite likely if it's a fire smoke. If it's a smoke only, you won't have that. We do have one, so it extends into the duct, and here's where the actual thermal disc is, bimetal. And if it pops open, it is manual reset. It has conduit connectors and wiring connectors in it. Torque, the damper manufacturers vary a lot from what torque is required. So what I've done here is, this is sort of the rules of thumb. They're in all of our instructions, and we do have a general pneumatic to electric instruction. But those give you good damper sizing, how much torque. We don't go specifically by torque. We go a little bit more by what's past UL 555. But at 2,000 feet per minute or less, these numbers are quite safe. Now, as soon as you start to hit, start moving above 2,000 feet into a high pressure system, you got to start to shave how much damper area you're going to get out of any actuator. You can always call us and we'll work it out. Actually, we've never had any real troubles because we're conservative on our numbers. We do have retrofit instructions on our website. It's www.belimo.us/fire smoke. Get you onto the page that has all kinds of instructions. And on this page, there is a pneumatic to electric. It's right here. It covers a little bit more than I'm covering here on the controls and shows the general mounting ideas. It's also something that can be submitted to the fire marshal or building official for approval if you're getting a permit. And on pneumatic versus, electric, well, you're going to need an electrical permit. That is the end. I'm open for questions. And there's my email address there if you need to, want to send me any specific questions, and I would try to help.
All right. Thank you so much, Larry. So if anyone wants to ask a comment or ask a question or make a comment, what you'll need to do is open up your question box and type in your question. I will then read it aloud, and Larry will answer it as best as possible. As a friendly reminder, this webinar has been recorded and will be posted to our Belimo YouTube page. It also will be emailed to you in a thank you email that will come out in the next day or so. Larry, are you ready for questions?
Yes.
All right. First question, why do you start with the damper and not the torque of the old actuator?
Because a number of different methods were used for the spring return and for the controls. So you want to look at the damper, number one, to make sure that it's still functional, and then number two, to see what controls you had so that you can tell if you need to do more than just the actuator.
Okay. If you replace the actuator, will the dampers maintain their UL listing?
Not really. UL, and the UL statement is in every one of our instructions. UL says you can replace actuators. They merely state they're not in charge of that. Once these are installed, the authority having jurisdiction, the local inspectors, are in charge of them. And they won't recertify anything that is installed before the current or the present UL standards, which were set up in 2002. So anything older than that, they merely grandfather in their use, but they threw away all their old procedures, so they don't even have a list of what actuators were listed. So the accepted practice is use an actuator that is UL 555S listed and bring everything up to the current standards to every degree possible, and then submit it to the local inspector, and he's in charge.
Okay. What is the normal life expectancy of a Belimo actuator?
Well, projecting into the future is always hard. We started selling these in 2002, and our replacement market is negligible. So we're now seeing 16 years out of our first ones being installed. Belimo will always say 15 years, but I've seen 20 years out of them, and we can expect that. A lot depends on the service. If you're in a corrosive environment, adding torque, the lifespan could be shortened. But given our track record so far, we're looking at 15 to 20 years.
Okay. Does Belimo offer fire and smoke actuators with 250 degree and 350 degree temperature limits?
Yes. They are different actuators. Anytime looking at any of the actuators, and look at the spec sheet. Don't even try to use your memory. There's too many little details that change actuator to actuator. But yes.
Okay. What permits are required for a pneumatic to electric replacement?
Electrical permit, of course, would be required unless you already had 120 run up to the actuator. And then if you're going to be doing any structural changes, you're going to need a permit for that. Now and then we see drywall run so that we have to break it apart to get access. In that case, you're going to need a permit for the drywall. On the electric to electric replacement, most jurisdictions consider it to be a normal repair, and a permit isn't required, but you've got to leave a record on site of any changes you've made, any repairs, and also of your periodic testing. So sometimes you need an electrical, but not always, and sometimes, it's rare, but you might need a permit for the wall, the structural.
What's the regular maintenance requirements for the Belimo electric actuators? Annual, semi-annual, etc.?
There's no maintenance requirement. They need no exercising. They need no oiling or anything of that nature. However, there is a periodic damper testing requirement in the IBC and IFC, the International Fire Code. In commercial buildings, you've got commissioning, then you've got to test them at 1 year, and then every 4 years they have to be tested. Except in hospitals, it's every 6 years. That's for the containment, the Chapter 7 dampers. Chapter 9 dampers is going to be semi-annually if they are in a dedicated smoke control system, and it's annually if they're in a non-dedicated. And there's also a couple other code rules that essentially are all annual inspections, but those are the special dampers in the smoke control systems. Chapter 9.
Can you please repeat the code again so that they are able to go and check it out a little bit further?
I'm not sure which code you're speaking of. Does it say the IBC or IFC or?
It does not. Can you just repeat that, IPC?
The International Building Code and International Fire Code is the fire code that's most specific about periodic testing. It's after commissioning in the first year test, it's every 4 years. Except for hospitals, it's every 6 years. They can also email me if I'm not answering the question properly.
Okay, great. So I am going to do a last call for questions. I apologize in advance if we have not gotten to your call, but rest assured, Larry will reach out to you individually and provide you with answers to your questions. So Larry, are you ready for, I can take about 2 more questions. Are you ready for those last 2?
Sure.
Where is the best place to look to see which fire and smoke Belimo actuators are obsolete or no longer up to date?
Now that's a difficult question. Our Select Pro would say it. I don't know where we have the list of obsolete. Giving us a call is probably best. We've discontinued the original FSAF and replaced it with the FSAF-A, and we've discontinued our old modulating, the FSAF-SR versions, and replaced them with the B model. So there's only really 2 actuators that have been obsoleted series, and then we have replacements for all of them. Now my cross-reference does list all of them. It's in Select Pro.
Okay. Last question. Are there always separate fusible link air valves for every damper section?
No. Strictly speaking, that's no longer allowed. I've seen it in old projects, but you're supposed to have just one sensor that closes all sections at the same time. There's an exception to that where some of the damper manufacturers on their fire dampers can close the sections individually, but UL would, I don't know of any other exception. And on all these old smoke ones, you should go with one center that closes all the sections at once. What you don't want a high velocity coming through just one section that would keep the damper from closing, because high velocity will add quite a bit of torque load, and it could be that, unless it's been tested and proven, that the actuator wouldn't be strong enough. Say you had 1,000 feet a minute going through two sections, but one of the sections was small. You slam it closed, and all of a sudden you got 2,000 or 3,000 feet per minute going through the other section, and the actuator couldn't get it closed. So you should use one center.
All right. Well, this concludes our webinar. I want to thank you so much, Larry, for giving us that excellent presentation.
You're very welcome.
I also want to thank all of you for participating in today's webinar. Our next webinar will be on the 17th of October at 1 p.m., and it's going to be on our energy valve. I would once again want to thank you and have a great day. Thanks, everyone. Bye-bye.